Hey everyone, welcome back to Sensor Secrets. I plan on being here every Tuesday, sharing some real world tips from my over 20 years in the sensor and automation industry. All right, so in today's installment of Sensor Secrets, so our super sensor secret installment today is going to be on Sigma.
What the Sigma?
And sorry, depending on when you're watching this, maybe that's going to be a traumatic word to hear, depending on if you've got some younger kids. But I'm talking about the statistical topic of Sigma. How do we use it? What does it mean? So what I think is really important is you are in charge to find a sensor that has a precision, a resolution, a repeatability, an accuracy, let's say down to 1 millimeter. That's your goal. You need to measure or detect or maybe using it for quality control, and you're looking for a millimeter. You use some of our other tools here, like the Essential Guide to Sensor Selection, and you get yourself a sensor, and it has a spec of 1 millimeter. Great, that's what you're looking for. You get the sensor, you test it, looks pretty good. In practice, though, you start getting data and results that are wrong. They're no longer measuring to 1 millimeter. And again, this could be the resolution of 1 millimeter, the repeatability, just overall, I'll call it precision. But right now, you might think the sensor is giving you wrong data, inaccurate data. It's out of spec. And I'm here to say, no, the sensor is probably working as designed, but maybe we don't quite understand the design and the specs. So let's take a look at a couple things here. So let's say you went through the Essential Guide to Sensor Selections, or you saw some other videos on the W10 and how to work them, and you end up with the sensor. It's great. You're going to look at some of the technical details, and you're looking down into here and saying, okay, here's my sensing range. Yep, that meets what I need for my application. And then let's look at some values. Resolution 1 millimeter. That's great. Here's my repeatability. Ooh, it's better than 0.5%. Accuracy 4%. Let's take a look at the footnotes. Footnotes 1, 2, and 3. Like a lot of stuff, things in the details are really important. And so let me be your sensor lawyer and maybe try to walk you through some of these little fine details in the fine print here. Sensor manufacturers are not trying to be tricky. They're not trying to hide this. However, we got a couple things to look at. One, 90% remission factor. If you want a little bit more information on that, take a look at some of the other videos, specifically on the Essential Guide to Sensor Selection that we talk about, the color, even just recently, and I'll link to that as well. 90% is white. So 90% is white, 6% is black, 18 or 16 is gray. So what this is saying is this information we're giving you on the precision is based on a white target. Maybe you have a white target, but maybe you don't. Second, equivalent to 1 sigma. And then I'll get to that, but before we do that, also warm-up time, 15 minutes. Wow. But if you look at the temperatures, these sensors can run in. So let's do ambient data over here. -10. It could be stored at -40. So you got a cold storage sensor. It gets brought up to at least -10. You turn it on. In order for it to stabilize, it might need that much time. Most indoor factory automation applications, you don't need anything like 15 minutes. Okay, so let's get back to the important part here. I'm going to go back over here and we're going to look at these product features. We're going to look at that footnote, particularly the second one, equivalent to 1, and that is a lowercase sigma. So to talk about that, that is a statistical number that talks about error. So if you remember back to maybe an intro to physics class, and I'm going to show a little video clip here, that is based on a normal or a Gaussian distribution of data. So let's take a look at the numbers. 68% of the time, your values will be 1 millimeter. But on the outside part of that, 13%, 14% of the time, the values won't be 1 millimeter, within 1 millimeter. And 2% of the time, it's gonna even be worse. Let's take a look at this video. So this is a kid's toy. It's kind of fun to watch. But this shows a normal or Gaussian distribution that I'm talking about. So the data coming in, let's say from a sensor, measuring distance or see if it can pick up an object. 68% of the time on that sensor we looked at, you're going to get a millimeter of accuracy. It's going to be correct in its position, in its measurement, 68% of the time. And that's going to go flow out further and further. So you will get some data points that are on the outskirts, that are on the outside, on the tail ends of that distribution. And that's what's important to take a look at as you're trying to choose and test a sensor. So if you're wanting a sensor that is always good to 1 millimeter out to 3 sigma, you need to find a sensor that's maybe it's a 0.5 millimeters. So that all of the time you will get at least 1 millimeter precision. So it's very important. There's a lot of stuff you can look into. There's a lot of math, a lot of stats. There's all sorts of different distributions. But the important part to note is that if you want something good within a certain precision that you require and that you need, take a look at these footnotes. They're almost always spec to 1 sigma on a white target. So if your application needs better than 1 millimeter, or you need 1 millimeter in all cases, or you don't have a white target, you might need to find a different sensor. And you can use the Essential Guide to Sensor Selection to help you go, okay, what would be the next one? In this case, since you're here, if it's not the W10, maybe you need to go to the W4. Or there's other sensors. Contact your helper for sensors, application engineers, technical support, and say, I need something with a higher precision. And then definitely take a look at the videos here to help you out with overall precision. Couple things. One, to get the sensor you need the first time, to help you get to that solution quicker, faster, more efficiently. At the same time, to not have to overpay. You don't need necessarily to buy the best performing sensor, because if you want the range you need and all that precision levels, wow, it could be a very expensive sensor. They're available, they're out there, but maybe you don't need it. So to understand what these are for your application will save you time and money. So that wraps it up for now. Check back on more information, especially on Tuesdays. The Sensor Secret Tuesdays, we'll be going through more of these in a series. Also, please drop down into the chat and ask your questions, ask your put in your comments, even disagreements or different definitions, a way to looking at this thing in the comments. That'd be very helpful. See you next time. And explaining that, actually, it would be a super sensor secret installment. Yeah. I guess I have, it's not just alliteration. It's, if you can't read words that start with the same letter, that would be an alliteration.